I'll just give a very quick introduction about myself, Ashok, and have about 20 plus years experience in information technology. Last 3.5 years in big data and related technologies, analytics, data science, and related areas. I've done 3-4 projects in the big data space, and I also do product consulting besides being an educator. So today's topic is linear regression in R, and I'm really looking forward to spend the next hour or so with all of you. So I'm absolutely excited. I think there's a lot of lots and lots of participants today. I'm seriously excited, friends. Yeah. Okay. So let's take a small look. I'll friends, the way I want to structure this session today is, we will see um, because we have 1 hour, right? So the first hour, the first 30 minutes, I would say, let's look into linear regression a little bit. Let's see how we can relate to the actual real life, coming to the linear regression. And the last 30 minutes, I would like to probably show you a small, a demo, right? So that's the structure. So are you all fine with this? Okay. So how many people are familiar with regression, friends? Linear regression and all that. How many people are familiar? Quite a few of you are actually familiar. Okay, little bit here, there. I am, me, good, basic. Okay, awesome. I just curious to know. That's all. I'm not going to ask anything other than that. But it's good to know that people are catching up with this. So let me actually begin with let's go a few slides in deck, then I will come back to my, I'll take you through a whiteboard, and we'll get on to examples, right? So that's the intention here. So what will you learn today? What is linear regression, and how to design a regression model, how to compare regression models, hands-on part, right? So let's see. I have about 31 slides, so I may not, spend time in every slide. So I'll try to make, the best possible use of our 60 minutes here, right? So we are trying to give you a generalized introduction here. Suppose you are the owner of a restaurant, and where tips are part of a waiter's pay. So the amount, if you, as you can read from this, it depends on the total bill, right? So in different places, there are certain places like, they say 15% is mandatory, right? In especially in US and all that, right? So tipping is like and Europe. So some places it is optional, some, it is, but in many places, it has become a practice, right? So we can predict the amount of tip from using regression. This is where we are coming to. Okay. Let me just, so predicting the tip, if you're actually looking at the line, you don't have the data for the amount of the bill, but you only have the tip amount. And you have different meal options people have taken, right? 1, 2, 3, 4, 5, 6, and all that. So all you have is the tip amount. Now you want to know, hey, you are trying to predict the tip, correct? So this is what you are trying to have. So let's say first meal order, it's like, this is the $5 and $17 and things like that, and so on and so forth. And if you see, visualize the data, they are just plotting it, meal in the x-axis and tip in the y-axis in dollars, right? If you look at it, if it is just plotted, right? So what does this indicate, friends? Can you all tell me? What is this plotting? Scatter, exactly. Yeah, it is just plotted in a very scattered fashion, right? It's a kind of scattered plot, right? So let's go a little further. So this is what I have, but can you make out anything by looking at this? So what is that? How can you predict the tip, right? So if you look at this, how can I predict the tip amount? Correct. So this is what we are coming to. So based on whatever we have, we are trying to find the mean of the tip amount, right? Mean is nothing but, I need to find an average, correct? I'm trying to find an average. So if I find an average, it comes to like, uh, approximately 10, correct? Not approximately, exactly 10. If you look at it, right, 22, 33, 41, 55, 60 divided by 6 is 10. That's exactly what we are getting, correct? So if I draw a line, so all the plots, right, you can relate to this centered line, which is calculated out of mean. Now I can make some sense out of it, right? So let's go a little further to understand what is what. The best estimate is kind of $10 because mean of the tip amounts. Note that you have only one variable, no other information. The best prediction that can be is the mean. It can be the mean itself, correct? When you have only one variable. But ideally in regression, I mean, here we are come to the conclusion of this tip problem. But in ideal regression, right, you may have one dependent variable and there will be multiple independent variables, right? Multiple independent variables. We'll come to that, correct? We'll come to that shortly. So, it's just an extension to whatever we spoke, right? So we have things like, residuals. Residuals is like, it's the deviation between actual and estimated value, right? So for the sixth one, right, if it is 10, whereas the amount was 5, so it was -5, it is +4. We are just plotting it based on the intercept value, whatever we got, right? The mean value. So we are trying to plot, I mean, we are trying to find the deviation here, right? We are trying to find the deviation here. This is again a illustration. Then the sum of the residuals, by all these things, right, if you make it, it becomes 0. So if you add up all the positive and negative deviation, you should get 0, correct? Because 10 is the mean here. So in other words, amount of positive and negative deviation is always the same, okay? Because the amount of positive and negative deviation, correct? So it will be the same, 12 and 12 here, right? Whatever is the deviation once you have plotted it, correct? So now for us to get a pronounced, sometimes the deviation is so less, and also it will come in negative and all, right? What we do is we typically do the summing. Negative values, Jaya, the point is, see, okay, there is a question here. See here, 10, right? If you look at it, the first one, right, I'm making -5 because the average is 10, right? So the first one, the value is only 5, so I'm getting -5. Jay, are you clear now? Yeah, similarly, so this is, you are getting +4 here because you're getting 14, correct? So that's how we are getting. So sum of squared errors, you should get 120. And what do we need to get from squaring the residuals? The goal is to create a linear model which minimizes the sum of errors, correct? So that the deviation is more emphasized and make it more obvious, and it helps in comparing different analysis models. No, Hardeep is asking sum of square of residuals. So this is what, -5, it becomes 25, right? Hardeep. So if I sum everything, it becomes 120. If I add up all the squares of the residuals, right, it becomes 120. So this is, if you look at it, right, this is 74, 75, 79, 95, 120. Sure. This is how we are getting, adding all the residuals. Exactly. Yeah. So, yeah. And if you look at it, improving the current model. So I'll just give me a minute, friends. I'll just see how much we can have. Okay, before, yeah, only 2 slides. So I'll come back to that same part. So the tip of the waiter depends on the amount of the bill. We all know that, that's the actual model. Till now, we were just using the previous tips to estimate the value of next tip. correct? So we will design a regression model which will estimate the amount of the tip depending on the billing amount, correct? So this is what we are trying to say. So this is the billing amount. What is the tip? So this is the respective amount. So the tip of the tipping amount actually goes up directly proportional to the bill amount, right? So this is what you are saying. So we are trying to do a linear model here. Visualize the data again. We have plotted it. This is the bill amount. This is the tip amount. Correct. So the same x-axis, right? We have put the bill amount and here is the tip amount. Okay. Now, before I jump into all this math and everything, right, friends, let me demystify because, friends, am I audible in the first place? Alka says I'm not audible. Am I audible? Okay. Okay. Thanks. Others can hear me out clearly. Let me say that. How is 34 and the last one tip of rupees 5? Just a second. Narshima is asking. Last two lines. No, no, no. Alka, what I'm saying is here we are again plotting the. See, earlier we put 1, 2, 3, 4, 5 and we plotted the tip amount. Here we are plotting the actual bill amount and we are trying to come up with a linear regression model, right? And how we can predict the tip amount. In previously what I told you was to use the tip amount to predict the tip amount. So we took the average because there is no other independent variable there, right? We took a mean. Now we have the bill amount, so we can use we are trying to plot it so that there is a dependency here. So the bill amount, any fluctuation in the bill amount, it leads to a the tip value keeps changing, right? So we are trying to plot this and develop a model. This is what we are trying to do. Yeah, this is what we are trying to do. So let me not get into this, friends, for now. So what I will do, just a second, just give me 1 second. There was one other question which I didn't answer. How is 34 and the last one tip of Narshima? Did I answer your question or not yet? Okay, okay, you got it. Narshima, did I answer your question? Okay, I didn't hear from him. Not really. Okay. Just a minute, friends, before I switch back to the whiteboard to actually take you through the linear regression, right? So that I'll make it simplified. I don't want to talk too much of math because some of you are not familiar. So I just thought I'll take you through a basic one. How is 34 and the last one tip of uh, okay, okay. Narshima says that's correct. See, he says 34 is 5, 108 is 17. Everything is, it is all going up. But this is like, how is 51? 51 should be actually, the tip amount should be little higher, right? Instead of, so that's what is that your question, Narshima? Yes. So it is possible, Narshima. It is possible to have these kind of values as well. See, it is like, we always use a regression model to do prediction, right? So the prediction can have, here and there, sometimes the values, right? It can be here and there, although it is directly proportional on all, but yet sometimes, it also happens in this way. Sometimes you may even get a skewed or outliers and, those kind of data as well. It's possible. But by and large, we see a pattern, right? Of course, this is a little skewed data, but by and large, we see a pattern in all these things, correct? Correct? Yeah, sure. Percentage, it's not, yeah, it is. It's not exactly percentage, Gurupal. I mean, we will see how we can model this, right? So I'll tell you, I'll begin with a small example so that, you all feel comfortable. This is where I am coming to. So let me take a simple notepad, right? Let me use a simple notepad and I'll ask you. So before I, before I ask you something, I want to just real time depends on person to, yeah, Jeevan says in real time it depends on person to person. Somebody who's a frugal guy, may not even tip, or somebody who is like a very generous, they may tip even, a lot of, they may a lot of money as well. Yeah, the people who are taking corporate lunches, dinners, they all generously tip because they always think they can claim it back from the company. So that is another part of the story. Okay, so friends, I want to tell you something, because I want you to know the regression, right? So uh, one thing is, we have it in the slide. It's to me, it is very mathematical. This one. See, once I go here, right? I think you will. I feel that you may get lost here. You may get lost here. So I'll tell you in a very simple way. Are you okay with the simplified approach? Is that are you all fine with this approach? Awesome. Awesome. Thanks. Because I want you to understand what is linear regression in the first place, right? So I don't want to just keep going with all the math and all that. So first, suppose you are oh, thanks. Suppose you are a testing manager, right? I want to begin with a very simple example. You are testing manager, correct? You are a testing manager for a manufacturing company or any kind of company that produces, let's say, some accessories for iPad, right? So you're producing that. So the acceptable rate is about 5%, let's say. Okay. Acceptable defect rate, right? You all know this, right? Defect rate, that is a kind of tolerance you can have. So in other words, if there are 100 devices you're producing, 100 accessories, right? Of same accessories, right? 100 accessories for that device. Okay. Uh, um, 5 can be defective, so that's the, which is kind of okay according to, because you are saying the acceptable defect rate is 5%. So the how are you getting this is, it's actually from the historical data. So if you want to verify this manually, because you are going by the historical pattern, right? If you verify this manually, you find it only 4.7% instead of, on 1 month data, right? You are taking the 1 month data and random, you are verifying, you are finding it only 4.7%. Okay. So what is the kind of inference you can come up with? Am I, are you getting what I'm asking, friends? I'm just leading you to a couple of terms, right, which I want you to know. Sure. Okay. Before that, I want to say, Amit is saying, how did you come up with bill and tip dependency? There may be some other possible dependency that may change the significance. Absolutely correct, Amit. Just for this example, right, we are saying bill amount and tip. If there are other parameters, it will definitely influence the significance of the model. You are perfectly right about that. Right. So friends, what I'm saying is, uh, what we are, see, there are two inferences you can come up with. You can say 4.7% is the correct one, right? Where, which is, so there is something called null hypothesis and there is something called alternate hypothesis. So I just want to spend like a couple of minutes on this because, you will be using this more and more in the regression and all that, because that is how you talk the business language, right? Okay. Now, my point is like, in null hypothesis, the sample data as well as the population is the historical data, okay, are the same and they are not different. This is what we are saying. In alternate hypothesis, we say both are not the same. So we have something called a, p value, right? That is a probability, right? So we just say, if it is, if the experimental value of p is less than y, what we saw that, right, that intercept, then we can reject the null hypothesis. So this means the sample and the population are not the same, right? That's what we are trying to say. Otherwise you can reject the null hypothesis and say that, okay. So just to give you a more practical example, suppose you are developing a medicine for a life-threatening disease, right? Let's say that you are developing something. What will be the confidence level, friends? Just want to be, what should be the ideal confidence level here? Can someone tell me here? Manish, brilliant. Jeevan, yeah. No. Confidence level. What should be the confidence level? Okay. People are saying 100%, 100%. I like that too. But 95 is very less, right? Life threatening disease. If you say 50-50, right? Nobody will even touch that, right? 99 and above, okay. 99 and above is probably the probably, it should be at the high end of 99, right? Because you're talking playing with the life. Okay, so Hardeep says null hypothesis. No, Hardeep, simple thing I want you to remember, because I don't want to deviate away from what we are doing in this session. What I'm saying is the confidence, the null hypothesis is we are saying the experimental value and the historical, which is the population, are the same. Okay, if you reject the null hypothesis, that means it is alternate hypothesis, right? So that is the sample and population are not the same. That is the nutshell, Hardeep. Yeah. So what is the optimal value? You all said 99% or more, right? So 0.05 is acceptable. Divyanshu says awesome, correct. So anything that involves life of the people, that will have a very very high, I mean very less margin for error. So it should be even like 99.99, I would say, right? So that's the kind of thing we are talking about, right? So in other case, so like customer retention, let's say in other cases, right? Customer retention, improving net promoter score for a company. So it may be even 90% or 93% and so on and so forth, right? Because that's not a very critical thing. So it depends on the criticality and demand of a business. So if you need very very high confidence, so the experimental p value will be higher than the cutoff value, right? So we can, so if it is like 95% confidence level, population and the sample are different. So at 99%, they may be the same, correct? So let's go with some example. Yeah, Ram Kumar, I'm precisely coming there. So I want you to, because we will be interpreting using those terminologies, right? So I just thought I'll touch upon that. Suppose, I want to give a very simple example. You're all working for a real estate company, right? You are working, you want to predict the price of an apartment in a particular area, correct? So that's my example. Sure. Now collected you have collected the historical data, correct? So the point is you are working for a real estate company, you want to predict the price of an apartment in a particular area, correct? You have collected historical data. The data pertains to the price of the apartment with lots of different apartment, and you want to estimate what is the price in that area, correct? Okay, so what can be the parameters by which you can determine the price of the apartment, friends? Can you help me with this? Let me put land price. You can help me with some of the parameters. Okay, land price, Gurupal has mentioned. Circle rate, what is that, Nitish? Population density, construction cost, locality. I think you all have labor price, labor cost. Okay, solid experience here. A lot of people. Okay, commercial, commercial value. Okay, it's kind of land price, right? That's kind of square footage. Okay, how about value of land? Yeah, it's all the. What about this, friends? Crime rate, proximity to work offices. That's right. Locality, right? Somebody else also mentioned that. Amenities, I take that too. Proximity to hospitals, that is a locality for me. And amenities, distance from, yeah, distance. Yeah, I would put the distance from, you know, landmarks, right? Hospitals and all those things. Yeah, that's a commute, correct. Future plan, development plan, and all that. So there can be actually number of parameters, right? There can be number of parameters here. So what I can put, government laws, okay, I can simply put price of an apartment, right? I can put A plus B into, let me come to things here. Just wait for a minute. Uh, C into crime rate plus D into locality. I'll just take, yeah, that's it. Let's say, okay, this is what I have, right? Okay, G1 says builder also. Okay, yeah, I take all these are inputs. I just put few of them, whatever you guys mentioned, right? Labor costs, okay. Now, this is a very simple linear regression equation, right? So we can make an assumption. Okay, let's say, just for this, right? Let's say that, I want to just take, these two things, right? Just to make it easier for us, right? So let me say I just take only this because I know there are so many other things, as you rightly pointed out. So many other things are also, there is a dependency, but let's take, this is my price of the apartment and this is my regression equation just for this example sake, correct? So I'm taking A plus B into land price plus C into crime rate, correct? This is my regression equation. Now we all need to have the values for A, B and C. Okay, do you all agree with me? We need to have the values for A, B, C to predict the price of the apartment, correct? So that's the next question. So what is A, B, C here, right? So the price of the apartment here is the dependent variable, right? It depends on all these things, correct? Of course, it depends on land price and it depends on crime rate, correct? So you may be wondering, hey, what is A? What is B here? B is some kind of coefficient, you'll come to that, right? It's a kind of coefficient, right? Into the land price, the coefficient into the crime rate. So, okay, now what is A? So what I'm trying to say is land price and crime rate are independent variables, right? These two are independent variables. B and C are coefficients. Price of the apartment is a dependent variable. Okay, now you are pretty clear, correct? Now what is A here? Any guesses, friends? What is A? A is a constant. Okay, Ravi says, excellent. Base value, exactly, right? So no matter what, whatever is the crime rate, whatever is this, right? No matter what, this is the base value, correct? This is the base price. Okay, so I will have the base value coming in for, A refers to the base price. See, one thing is, one of the most important constraints in linear regression is the dependent value should be continuous in nature, right? In linear regression, I want you to understand this. This means, what we can say is it can have the range and it can take any value. In other words, there is no restriction in this example, right? There is absolutely no restriction in the price of the apartment. It can range from 100,000 or it can go up till 1 million or it can go to 5 million and so on and so forth, right? Hence we can use linear regression equation here, right? So we have this one is, coming to the coefficient part of it, right? We talked about B and C, right? Coefficient. We can have three properties as part of the coefficient. One is the magnitude, one is the direction, one is the causal, correct? So I just write it so that magnitude. I don't want you to feel threatened by all this, definitions. I'll make it super simple for you to understand. So that's why I took the whiteboard. Nature of the independent variable. Yeah, Nitish, how do we just, I'll answer a couple of these questions. How do we determine it should be linear? No, if it is continuous, right, Nitish? So that we can have a range. So that means I can have a linear here. If I have, you know, uh, there are so many other regressions available, Nitish, like logistic and all that, right? So logistical regression, if I have, uh, something which is non-linear, right, I'll go for such things, right? Okay. Now, what should be the nature of the independent variable? It is, we will see that Parameshwan, like see crime rate, everything has got everything will influence here, right? Everything will influence the price of the apartment. These are all influences, and we will have the coefficient. Okay. Uh, Kamtha is asking base price. Base price is only A here, right? Okay. No, the range. Now there is another question. You mean range as the limit? Ravi is asking when I say the range means it can take any value, Ravi. Yeah, it can take any value here, right? So coming to the coefficient again, back to our context. Here, the magnitude, what we are talking about, right? Magnitude is the amount, the coefficient is impacting the dependent variable, right? It is by this amount, right? If I say 1 here, right, 1.2 here, so it will be 1.2 into land price, right? Okay, that is what we mean by the magnitude, correct? Now, what is, let's say, if I say, let's say, I'm making it even more simple. Price of the apartment, I'm making A plus, let's say 5.5, I'm just giving a random number, land price, right? Now I have sliced the crime rate also here, right? So I'm taking only this. This is a base for me, and this is my coefficient, and this is my land price. Correct? Is that correct? So how do you interpret this, friends? Can someone uh, interpret this? A is a constant. Price will be determined. Apartment price, base price will change the factor of 5. Okay, I'm getting various. Okay, all right. So yeah, I mean, there are various people who have kind of told that correctly. Okay, so what I'm trying to say is any unit change in the land price, right? Any unit change in the land price impacts the price of the apartment by 5.5 times. Is it okay to say? I mean, I'm just talking the business lingo, right? So that's what we are trying to say here. So let's say the higher the magnitude, right? Higher the magnitude, more impact on the dependent variable, correct? Higher the magnitude. Fine. Now, if I say if I say 5.5, it can be even minus 5.5, right? Minus 5.5. So how do you interpret this? Again, it'll see the if I have a positive one, right? Let's say I put the same thing here. If I do this, something like this, right? Something like this. So the first example, it says 5.5 times it'll influence the price of the apartment by 5.5 times. Second case, any unit change, right, of the land price will decrease the land price by 5.5 times. Correct? That's the direction. That's right. Am I audible, friends? Okay. Thank you. Yeah. Thank you. So that's the direction. So this will determine whether it will be directly proportional or inversely proportional. So that's what we are trying to say. So what is causal? Causal is, we saw this, right? Magnitude we saw, direction we saw. What is causal? Causal is, we try to explain the relation between dependent and the independent variable. So it can be unidirectional or even bidirectional. Cause and effect. Exactly, Nitish, right? Cause and effect. This cannot be measured or gauged by domain or, actually we cannot just measure it just like that, right? But we can gauge it by, our business acumen or, domain knowledge. This is what we can do. For example, the crime rate, right? The crime rate, higher the crime rate, we say lower the price of the apartment, correct? If the crime is really high in a particular area, it really impacts the price of a land, okay, price of an apartment in the neighborhood, correct? So people wouldn't like to move there and all that. Is the reverse true? maybe or maybe not, right? Maybe or maybe not. Okay. The next thing is like um, someone who is very very familiar, right, with the real estate and all that may be able to answer this. This is what, because it's just not, it's not a logical stuff. I mean, it can be a bi-directional thing, and somebody who is very familiar with the domain or somebody who is very familiar with the business knowledge can answer this question, right? So that's what we mean by the causal. Okay, so friends, yeah, I think Jeevan, he says, please hurry up, 35 minutes up, spend more time on or please. Okay, sure, Jeevan, I'm getting there. So I have an example to show you in R. So let me go there without further ado. So let me show you a simple data set. So are you all getting the basics of regression before I go to the R example? Are you all getting this clear? Okay, sure. Awesome, thanks. So I'll go to the R because the slides, it's I already have typed what is the example I have shown. I mean what I'm going to show here. So I'll show you the data set first. Just a second. Show you the data set first. Um, what you do with this equation, Ravi, I'll come to this. I've shown you the taste of linear regression, so we will see from a actual thing, right? Okay, so we will see what we do here. I'll exactly show it in R, so we will know how to build a model here, correct? So what we are seeing here, this is a data set, correct? This is a data set. Just give me a minute. I'll just pull this data set. I have half of this. Just a minute. Okay, so I have like 10 students here. Okay, if you look at this, I have their grade point average in their high school, what they got, and they are in the freshman, they are in the college. So using this data, right? Using this data, I am trying to predict what can be the score when they go to the college. So this is what we are going to do. Are you all clear with the problem statement, friends? Okay. So what I'm trying to do, first thing, I am reading this, right? We are trying to build a model that can predict the grade in the college that will be dependent on the grade in the school. Okay, this is what we are trying to do. We are using linear regression, right? We are using linear regression. Okay, so let me execute this. First thing is, I'm just doing, I'm just reading this data set. Okay, now I'm doing I'm just putting that to a variable. Okay, high school. If I do a summary here, okay, so, and this is going to give me so it gives me the minimum, first quartile, median, mean, all these things based on the data what I have here, right? This is what I have. This is what I have. Okay, and I also have, if I want to see the structure, right? If I want to see this, so it is having like, these are the values I have, right? I have 10 objects of 3 variables. This is what I have. Now let's plot it, friends. Let me just load this. Just give me a minute. Let me plot. Okay, I have plotted it. I have the high school GPA here and the, just a minute, I'll just show you. This is what I have. High school GPA and freshman GPA in the y-axis, correct? This is what I have. And let's go describe plotting. No, plotting, I just say what is the x-axis and y-axis, Arpit. Okay. So what see, we already have this, right? Freshman HSGPA and yeah, as per the, we have exactly read this. This is what I have, correct? These are the variables I've used, and these are the values I've used for plotting, correct? So exactly I've done this. Now, if you look at this, right, let's look at this scatter plot. What is the correlation, friends? Just let me pull this. What is the correlation here? If you look at this, what is the correlation? Anyone here? The axis, no, the both the axis. Oh yeah, it's a positive correlation. Excellent. Yeah, the axis, both x-axis as well as the y-axis. It is it's actually, both are numeric in nature. If, as you see, the high school grade is more and more, when it is increasing, right, the GPA, freshman GPA is also increasing. So this is what we are seeing. So it's a positive correlation, correct? It is an increasing order. What kind of coefficient value do you expect here? Is it positive or negative? Can you tell me quickly? It's positive, right? Straightforward. So to run the linear regression model, so what I'm going to do is, so let me come here. I think this is what we have plot. So I'm simply going to run this, friends. This is my linear regression model, right? If you say LM is the function linear regression, so I'm simply passing this. The LM is linear model. The argument is, the first thing is the dependent or the target variable, right? This is my dependent or the target variable. And what is the independent variable? Anything that follows the tilde symbol, right? That is the independent or target, right? Freshman GPA, whatever that follows the tilde operator or the independent variables here, right? So there is only one independent variable here because it's the GPA, but I can have bunch of them here all grouped. If I have like, 4 or 5 of them, I can always have. So if I have like, suppose I have, just for example, I want to quote it. Suppose I have many of them here, right? I'm sorry. If I have like, HSS, just dollar $HSS, GPA2, right? So I can go on having like this. Whatever that follows tilde operator, it can come here, right? So in short, anything that comes after the tilde operator or independent variables in the linear model. So that's the point I'm trying to say. So we can also write the equation as, we can also write it as, model HS, and I'm sorry, I can put it like freshman GPA. This also is possible, right? So if I want to take care of all the things, right? So it will take all the independent variables, right? So instead of defining each and every independent variable, you can, all the ones following tilde will be considered for this model. If I have like 5 variables, I have put the one before the tilde operator, one variable, the rest of them will be independent. So let's see what is getting outputted here. This is what I'm curious to know, right? This is what I have. So can you see the output? The college grad. So can someone, if I can make out what's exactly, if I need to interpret this, uh, what I have from the LM, right? This is what I'm getting, right? Residuals, median, max, coefficients, intercept, significance, residual error, it says this, right? So if I need to make some conclusion, let's focus on four significant ones here, right? That's why I had to tell initially about those p-value and all that. So where is the p-value, friends, here? Can someone point me out? Where is the p-value and what is the p-value here? Okay, Arpit is spot on. Yeah, sure. 0.252, correct? This is the one. Yeah, that's right. Okay, this is the p-value which is coming out of this experiment. And 0.6465 is the estimate, correct? Estimate, and multiple r squared, if you see, right? 4843. Just a minute. This is the one, right? This is what I have. And adjusted r square is, where is adjusted r square? It's 421, correct? This is what I have. There are four values that we can verify the summary of linear regression model. There are so many other things too, but these are the four significant ones here. So what is the estimate? The estimate is the business. See, if I need to say that in the business sense, a unit change in the school grade will increase the college grade by this many times, right? By this many times. Is this correct, friends? Is it okay to say that? Okay. So the magnitude, in other words, it is 0.64. No, okay. What I'm saying here is a unit change in the school grade, right? Okay. Will increase the college grade by this many times. So this is exactly the magnitude, Nitish, right? So this is, the direction is positive or negative here? Positive, obviously. So what is the intercept here? What is the intercept? Okay. So you're all, yeah, 0.4339, as a couple of you have pointed it out, right? This is very clear now. Okay. So how do you interpret this? Can someone give it a shot? How do you interpret this? Base. That's right. This is the base constant. So this is the minimum value of grade in college, right? No matter, in other words, right, I can interpret it this way. No matter how much a person had got in the school, a student will get 0.4339 at college. So this is the base value, right? So that's your intercept. So what is 0.0252? How do you interpret this? What is this then? That is a p-value you all told me, but what is the p-value here? I mean, how do you interpret this? So what is the null hypothesis, friends? What is the null hypothesis? High school grade. Can I, how to arrive? No, I'll call, no, let's not, how to arrive, it is the linear model, it has calculated this for us. Okay. My point is, how do you interpret this p-value? Can I say that high school grade does not depend on the school grade? In other words, the independent variable, right, does not impact the dependent variable. Both are same. That's the null hypothesis, right? That's the null hypothesis. Correct. Now, what is alternate hypothesis? High school grade has an impact on the college grade, right? So that's what we are trying to say. Okay. Now we have, let's say we have 95% confidence level, right? So our cutoff p-value, what should be the cutoff value if I have the confidence level as 95%? Can someone tell me? Exactly. Yep. I mean, a 0.05. Yeah, 5% or 0.05, right? Now, the experimental p-value is lesser than the, what is the experimental p-value? This one, right? This is the one. it is actually lesser than the 0.05. So we can actually reject the null hypothesis, right? We can accept or reject. Someone mentioned it some time back, right? So we can reject the null hypothesis. So it proves, so what it is proving here, it proves the high school grade has an impact on the college grade. So high school grade is a significant variable in the determination of the college grade. That's what we are trying to say. Are you clear, friends, so far, whatever I said? Yes? Okay. Now, let's look into multiple r squared here, right? So let me just spend a couple of more minutes here. Multiple, what we are trying to say is multiple r squared we got, right? This is the one. What we are saying is amount of variation of dependent variable which has been explained by all of the independent variables, right? So to what extent the independent variables can explain? Ideally, we expect the independent variables to explain the dependent variable, right? Completely. So what should be the ideal value for uh, you know multiple r squared, friends? What do you think should be the ideal value? Fantastic, Pranit. Anybody else? So what we are expecting is we expect the independent variables to completely explain the dependent variable, right? So a dependent variable which has been explained by all of the independent variables. So ideal value should be 1 exactly, right? So but it is very hard to get 1 in most of the cases. So anything above 0.7 is considered good. So in this case we are able to predict close to 48%, right? Looking at this value, right? We are looking at a 48%. Now, if we go back to the apartment, what we saw, right? Okay, price of an apartment, if we say, let's say, this is where we were, right? Price of the apartment. Now, if you look at this price of A into land price, this is what we were saying plus crime rate, this is the equation we gave, right? Initially. Now, let's look into there is something called adjusted R square. We saw this right here, adjusted R square, which is 0.421. Right? 0.421. Let's go back here. Okay. So what this means is, let's say multiple r square value will actually increase as we increase the number of independent variables, right? Okay. Higher the number corresponds to higher accuracy of prediction. So instead of giving me just one variable, one independent variable, if I have 5, my degree of accuracy, my accuracy of the prediction actually goes up. So can you explain better using less number of IDVs or independent variables or more? The answer is more. But let's look into the adjusted R square. We just saw it as 0.421, right? Now this is same as the multiple R squared in this example, at least. It appeared same. It's almost like, it's almost same, though there is a bit of difference. Yes. So only thing here, it is not sensitive to number of independent variables, the adjusted R square, right? Unlike this one is sensitive to the number of independent variable, right? Here it is not sensitive, correct? So what you are saying is, if I'm predicting 10 independent variables using 10 independent variables, the multiple R squared will be X. If you increase the number of variables to another 5, right, the multiple R squared will go up even more, right, this value. Whereas if I make it 20, it'll keep going on. Okay. But beyond a point, right, it may not be very substantial. If I make it 25, 28 and all that, it may not be very substantial, but there'll be a little bit of changes. But it is, bottom line, it is sensitive to the independent variable, right? Okay, it will sensibly increase. Whereas adjusted R square, right, it is not, impacted by the number of independent variables. It will only increase. Like if you have a scenario in which you have some independent variables makes multiple R squared actually going up, whereas it may not really impact the adjusted R square, then the variable is not really significant. okay, for the linear regression, and you can even avoid those variables, right? So something which is not really significant, right? You don't need to, let's say, a milk booth is there in your near your apartment. Is that going to really matter? Does it really matter in the price of the apartment? Probably no, right? Probably no. So you don't care about those things. You don't worry about those variables. Am I audible, friends? Okay, because at least 3 or 4 times, somebody suddenly said, I can't be heard. Okay, so what do we infer is we should create an equation with more number of IDVs, independent variables, or less number of independent variables, or just an optimal number. I think you will go for the optimal number, right? Having too many variables is also going to be chaotic. It's better to go with an optimal number because it becomes difficult to handle too many independent variables as well, right? So let's look into the prediction, which is probably the last part here. We predict two sets in this case. Why we need so many independent variables? No. Jaya is asking linear algorithm. No, we used only two, Jaya, but we can have many. We can have many, right? But all I'm saying is there are the the ones which doesn't impact the R square values, right? You don't need to worry about those variables. That's what I'm trying to say, right? That doesn't impact. Now let's look into the prediction here, right? We haven't executed this. So prediction. So what does this say? Let's say, see the values here, and let's compare it with the data set here, right? Let's compare it with the data set. Uh, 1.7, if you look at this, right, this is what I'm predicting using the value. It says 1.6, it's 1.7, 1.85, it is like 2, 2.11, it's 1.8, 2.17. If you look at this, right, 2.76, it's like 3. This is by the prediction. These are the actual values, correct? So what is the, then when you have the actual values and when you have the prediction, we can always look at the next thing is how do I calculate the residual or error for student 1, right? I mean, you can always see this, right? So it is like 1.76, I'm sorry, 1.6 minus 1.6 minus 1.72, right? I'm sorry, here. This is my residual. So it is, if I calculate this, right, that's what it's going to do. It's minus 0.12, right? So let's try. If I print this, right, it says this is what it's trying to say, right? Similarly, if you look at the second one, 2 minus 1.5, right? So this is the one. Similarly, it has done this. So what are these values? They are the predicted values, and we have also calculated the residual values. So this is to verify the difference. Okay, so this is what we saw it just now. Let's assume, friends, now that we have predicted, so what are we going to do with this? Let's assume that we have a new data of high school grade and we have to predict the college grade, right? So we are actually taken some kind of historical data and come up with the model, right? This model is fairly, it has got some level of accuracy, right? So if we have a new data, right, new model, new data, now what we can do using that high school data, new data, right? I can use a prediction algorithm. I can very well use this model. This model is already there. So people also say, right, friends, the more and more you train a particular model, right, it becomes more and more efficient. Is that correct? So, I mean, I have like historical data, like 1 month, right? The accuracy will be there. The more and more I go on and train the model, okay, it can become very, it can become the accuracy will be far more higher. Is that clear, friends? Whatever I explained to you so far on the linear regression, we will skim through the deck. I think um, little bit before I take up questions. So let's say, is adding more data will train, exactly, Nitish. Yeah, train the model. Yeah, more data in the sense more and more you train the model, right? The accuracy will be more higher. I think how many people, you all, the way people have devised chess and all that, right? I think Deep Blue was one of the things which even defeated Kasparov at one point, right, in the 2000. Now they've got the most powerful chess engine, which is called Komodo. Its rating is far higher than even Carlsen, right? It is like it is just thrashing all the opponents today. A lot of people are playing with that. Komodo is a computer, right? More, it can think through multiple possibilities. It is designed by human only, but it can just think through multiple possibilities and it can play, right, in the chess. Okay, just a second, friends. Let me skim through the deck what they have got to say here. Mean value, given value, linear regression. Just a minute. Okay, narrow distribution is always better with a instead of a broad distribution, so that makes it okay. Closer look. Just a minute, friends. I'm trying to see what are the areas I can explain a little more. Okay, looking at this, yeah, this makes it a little more sense here. Tip deviations, if you look at it, they've calculated the slope, they've calculated the intercept here. 6, 34, 5, x minus x intercept, y intercept, just a minute, minus x squared. Bill deviation, if you see this, tip deviations, deviation in the products, bill deviation square. If they, so it comes to, they put a total here, it comes to 4206. So I'll see where they have plotted it. I'm not seeing it yet. Just a minute. Value of the slope, calculating it here. Okay, this is the formula they've calculated it. Value of y-intercept is this. This is the average what we saw, right? And put the values of intercept into linear regression equation. See, it's the same thing they've done, right? The direction, the base value, whatever we have seen so far, right? So using this calculator, they are using this as the predictive tip amount, right? What can be the predicted tip amount based on the bill price? They are using applying a coefficient value, okay? And there is a magnitude here, right? Observed versus predicted. Then they will obviously go for the residual here. Let's see whether they are bill amount and they are plotting it as well. Just a minute. Residual, yeah, obviously they are coming to that. The same thing whatever we saw, right? So what is the predicted, what is the observed, what is the actual one versus predicted, right? So for some cases it can be positive, for some cases it is negative, right? This is how it will be. How did we get 0.81? Yeah, that's what Devrani, the whatever is the, this is the observed and this is the predicted, correct? This is what we are getting. So just a minute. So I'll see bill amount again they have put with residuals, which is the error here, right? Squaring the residuals, as we saw in the in the very first example, right? In the so that this results in positive value. The second approach, better estimate that decreases the sum of the squared errors. Okay, this is the dependent variable and independent variable. Tip amount as a function of meal amount. So this is what we are getting. So okay. So friends, uh, I thought I would rather explain you in a very simplified way and come to this. So did you understand? I'm. Did you understand the linear regression? Did you understand how we went about it? Did you understand how we did the prediction subsequently and the residuals? Did you understand these 3-4 things, whatever I just mentioned, conceptually as well as the how to train the model? When I'll come to that. Uh, okay, 75. Okay, Nitish says 75 out of 100. All right. So that's your. I have got. Sure. I think that's fine. What about Sudhakar? I think Sudhakar was asking something. Sudhakar, are you fine so far? Sudhakar and few names which I just remember uh, out of my head. Nitish, Narsimha. Okay. All right. Hardip, repeat the terms. Okay. Thanks. Okay, I'll just repeat Ravi has told. So I'll just summarize it so that you all stay clear. The first thing, friends. Okay, I'll also say, there's something called how to train the model, right? So there is what we do, friends. The thing is, before I come to training the model and all that, the first thing is I want you to, in this we for predicting the regression using a regression model to come up with a prediction algorithm, we always try to first, you know there is one dependent variable, right, which will be dependent on multiple independent variables. These are all they will be used for prediction, correct? They will be used for prediction. So what we typically do is we will simply take, one by one, right? We will, try to form an equation and try to see, we try to see, what is a coefficient, what is a possible coefficient for different independent variables, and what is a base, right? And we use the function called LM in the linear model for the R, right? In the student grade, whatever I told you, right? I tried to, the actual values were here, and I tried to tell you what was the model that was predicting, right? So there were residuals. Residual is nothing but errors. So compared to the actual ones, right? Because this is the historical data I took, right? So my model was, the more and more I train, right? When I say training the model, if I feed some more data, right? The next time, I can, the accuracy will actually go up. So if I feed with more and more data, my model will become more accurate as I keep entering more and more values, right? In the sense, I may also fine tune the model, right? So it becomes more accurate with more data. Instead of, say, it's like saying, friends, very quickly, if somebody gets like, one person says, it's very simple this way. If one person says, hey, you are a rock star, right? You will think, okay, you may feel flattered, but you are like, okay. If five people say, you are like, yes, you are like, okay, you feel somewhat good. If 100 people say, right, it's much better. So in this case, it was like 48% confidence. That's right, Nitish. Yeah, what we saw here, correct? So it may become higher and higher, right? May become higher and higher as we move forward. So that's how you train the model, right? And finally, the model becomes so clear. So it is like you can literally predict, given the data of grade point average of high school, you can almost accurately predict freshman GPA, right? Is that correct? Correlation is zero. No, then it becomes okay. What Vivekanand is saying, if the independent variable, if there is absolutely zero, right? So uh, uh, what will be the what to say? What will be the freshman GPA, friends? In this case, if the freshman, what will be the prediction? Sorry, let me frame the question differently. If what he says is like the freshman, if the correlation is completely zero, how do you go for regression? That is what Vivekanand is asking. Can someone answer this? Because we have understood it. Let me check that. Can someone try answering this? Okay. Um, Vivekanand, the point is, as we saw, the coefficient, if it is like totally zero, let's say, right? Then it can, it will very well take the base. That's it. Whatever. See, the base also we saw, right, Vivekanand? what I was trying to say, this, what is the base value here? In this case, we saw it here, right? Can you tell me again? What is the base value? It is the intercept, correct? It is the intercept here. Yes. So no matter what, the point is, whatever is the thing, right? The base value, it is like, the, no matter what, how it, how the freshman performs, right? How they performed in the college, they are going to get that grade, right? In the freshman. Okay. So that's what we try to interpret here, correct? That's what we mean by this. All right. So just a minute, friends. One other thing I want to tell you before I. Uh, what if the Ranjan is asking? What if the base value is not significant in the first place? Okay. The variables base is, that's, see, the variables, the significance, insignificance, it is generally attached with the variables, Ranjan, right? So which are the independent variables, right? So this is what I have used library for what purpose? To for this linear model equation, Jaya, right? Correct? So I need to use all these things. Especially, if I need to describing the data and all that, right? So I need to use this. Okay. Any other questions which I need to take? Did you all understand? One thing, I again missed out. Did you all understand? Did you all understand the, uh, you know, given the fact, you have this dependent variables, independent variables, then you have the base value. I mean, you find out the base value, you find out the coefficient of different independent variables. Then we saw the R squared, we saw the adjusted R squared, which is insignificant, which is not, you know, uh, which doesn't really get impacted by the number of independent variables, whereas multiple R squared, yes. Okay. And okay, so this is what we saw. So what, okay, Nitish says, I got, which other method can help us to do the same? Let me answer this. Jeevan, there are like, when you actually do multiple, there are several regression techniques available, friends, right? There are several regression techniques available. You need to take which is the best one, which gets closer to your, which provides higher accuracy, right? So here we are talking about linear regression here, and we are using this, right? So there are different regression techniques available. So you need to use which is the most appropriate for your kind of business and for your kind of analysis. So that is absolutely in your hands. Okay. Now Nitish says, I got accept hypothesis. Okay. See, the hypothesis, what I'm trying to say, Nitish, just you try to understand this, it becomes very simple. Okay. What I'm saying is like, we did all these things, right? We did everything, the college grad, and what I'm saying is the null hypothesis here, in this case, like I'm saying the both the experimental value and the population, which is the historical value, right? I mean, I'm saying the high school grade is not dependent on the school grade. I'm sorry. Yeah, this is what I'm saying, right? Now you can reject this hypothesis on a confidence level of, let's say 95%, right? That's my confidence level of 95%. 95% means my p-value probability value should be 0.05, right? If the confidence is 95%. Since it is lesser than that, right? The experimental value is actually lesser than the cutoff value. So I can reject the null hypothesis. That is what I'm trying to say, Nitish. Yeah. Okay. Adjusted or squared. Okay. Let me explain that again. Just a minute. See, adjust. So there are two things, right? Multiple R squared and the adjusted R squared. Okay. So the more and more number of independent variables, right? If I add one more, right, this may actually go up. Okay, this will impact, whereas adjusted R squared, it is actually, it doesn't get impacted. Okay, it is like, it is not, it doesn't impact even if I add more number of variables, right, independent variables, it doesn't get impacted here. That's your adjusted R squared. Vinayak says if correlation is zero, no linear relation exists. Yeah, okay. Anything else, friends? Did I miss out any questions? So adjusted, it's like, it's moral, if I want to say, it'll sensibly increase, right? It'll not just merely increase by the number of independent variables, right? So it'll sensibly increase. Let me put it that way. If we choose type of regression, then variables we rely on historical data. Is it the correct order? Yes, Nitish. See, the more and more you do, right, more and more accuracy it becomes, right, over a period of time. It's just like, picking up a skill, right? Once you become more fluent, right, you get fluency by experience. Similarly, what degrees of freedom? Jeevan, can I understand what is this question? Like, what degrees of freedom means what? Can you articulate it a little bit? What does it mean? I mean, what is the context here? I don't get what you're asking. Sorry if I didn't get that. How residual value help in real life? Okay. Okay, residual value, Nitish, the point is, see, that is like your error, right? That's an error for you. So going forward, right, the more and more error you're getting, right, you'll try to minimize it, right? So you know the deviation from the actual versus predicted. So you can try to fix this over a period of time. Do charts look boring in R? No, no. Actually, Indica, the point is, R is one of the best in data visualization. It is one of the best. So I showed you a very dumb scatter plot. Sorry about that, but I can, you can really add juice and spice to make it a lot more interesting. Agreed, and it can be done for sure. But this is a very straightforward scatter plot. Whatever you're seeing, right? That's what you're seeing. But it is not at all boring. Trust me. But it is almost in the Tableau. If you see that, right? It's beautiful. Tableau is beautiful, and R has the visualization support plus your statistical formulae and all that. So that way it is very effective. Yes, Hardeep. Yes, residual value. Yeah, exactly, Hardeep. Yeah. Nitish says I use Tableau too. Yeah. Okay. Sure. So friends, I hope I was able to make some sense out of today's session. Uh, hope you all enjoyed it. R squared, more and more independent. Other access, okay. Hardeep says R square, more and more independent. Other access, XY gets impacted. Um, see, R square, right? See, what I was trying to say, Hardeep, the R squared is like, as I told you, more independent variables, it becomes, that's the percentage of it we can actually determine, right? Percentage of accuracy, right? So it'll the higher the percentage it will become, correct? The accuracy is the one which is getting determined here. Yeah, confidence level. Base book for analytics here. Will you send us a recording? You will get the recording, Narshima, from Edureka. Best book for analytics. There is a book on business analytics and R. Uh, mm, you can just Google this, friends. It's a downloadable book available. You can download that. I think from Rocks Publications, if I'm right. So just go for that. Yeah, that's a very good book. So friends, I think we are already 23 minutes over time. Sorry about that. Um, so uh, Hope you all enjoyed this session. Hope you found it informative. So if there's anything, I'll see whether there's anything here else. Uh, okay. And finally, friends, you also try to, whether it's good or bad, right? Please uh, express yourself in this survey, because this is really okay. Name of the book: Business Analytics or Uday. Yeah, sure. And or programming. There are so many other books. There are so many free tutorials. You can go to Khan Academy as well. So lots and lots of things are there, Uday. Yeah, to get your concepts brushed up. So thanks, and please express yourself in the feedback survey. That will be useful for us. And thanks, friends. Good night, and hope you all enjoyed the session. Thank you so much.